Hello, everyone. My name is Brent Wagner. I'm a field security specialist at GitHub based in Japan. Today, I'd like to talk to you about GitHub Advanced Security. So I'm just going to pull up the presentation here. And this is mostly an interactive. I'll be walking you through the system. But to start out, I just wanted to show a few slides to give you an overview of what GitHub Advanced Security contains. So going to the next slide. So GitHub Advanced Security, firstly, contains a code scanning element. And within code scanning, it comes out of the box with GitHub's CodeQL SAST engine. And this is, we think, the best SAST engine that's available, but it's not limited to CodeQL. This is first and foremost a developer focused tool set. And we want to make sure that whatever developers are most comfortable with, they're able to use within the GitHub code scanning solution. So really the code scanning part of GitHub is focused around that developer experience. So we have secret scanning. Secret scanning will look for any type of API keys or authentication tokens or any sort of secret that you may have within your organization that you want to look for in your code base. And this will prevent developers from merging secrets into the main branch of the application. In addition, there's a GitHub security overview, and this is a single pane of glass report that anybody within your organization, not just developers, can use to understand in one place what's the overall security posture across your entire organization, across all of your repositories. In addition to that, we have GitHub supply chain dependency review. So this is two components. We have a dependency graph and we have Dependabot, which automates how to deal with security alerts that are raised against dependencies. Now, this is not technically a part of the GitHub Advanced Security product set, but it is included within GitHub Enterprise and is definitely part of your overall software security posture. So if we go to the next slide, this is just a quick overview. So GitHub delivers a complete application security solution. As I said, it's a developer first. We believe that if it's not a developer focused tool, then it's really impossible to shift your security left and expect your developers to be able to identify and address security vulnerabilities that are introduced at the development phase. It's also a native solution. It is part of the GitHub tool, so it's a familiar interface. It uses all the familiar workflows that your developers already know how to use, and it's fully automated. So your developers don't have to do any sort of, they don't have to take any actions. They just show up as alerts within their normal workflow. So that was a quick overview of GitHub Advanced Security. Next, I'd like to take you through the actual product so you can see what it looks like and feels like. So I've set up a demo here, and this is a copy of WebGoat from OWASP. So it has many vulnerabilities in it that we can see. So in order to set up GitHub Advanced Security, we go to the settings and the code security and analysis settings window. And this will include settings for dependency graph and Dependabot. So the software composition analysis tools, as well as GitHub Advanced Security, which includes code scanning and secret scanning. We'll start with the code scanning setup because it does take some time to run. So first we enable GitHub Advanced Security, and then we'll get the option to set up code scanning. So we click Setup, and this will take us to a custom action setup. So this YAML file, it detects what languages are in the project. It will set up a schedule and set up the runner that this will run from. For the purposes of this demo and for most use cases, you can just go with the default settings. So here I'll just go ahead and commit to the main branch for demo purposes. And you can see that the code QL analysis, that YAML file was created. So this will set up some custom actions, and these will start running now. So while these are running, I'd like to go back and show you the secret scanning setup. So we go back to settings and code security and analysis. So under secret scanning, it's been enabled by default when we enable GitHub Advanced Security. we have an option here for push protection. And what this does is it will prevent any secrets from being checked into the main branch, from being committed, sorry, by developers into their own branch. So this is useful for preventing any kind of secrets from being exposed, because if somebody's able to commit to their own clone, their own branch, it can end up being replicated elsewhere. So it's disabled by default, but we'd recommend enabling it. One other thing we can do is we can set up custom patterns. So GitHub partners with we have many partners to be able to identify different types of secrets. So for example, Azure tokens or API keys. But it doesn't detect everything. The number is increasing all the time. But you may have secrets that we don't have format for, and you can create your own through regular expressions. Or you may have secrets within your own organization that you want to look out for. So in this case, I've hid some keys within the project source code, and it follows this format of key underscore and then 3 numerical digits. And here we can test the regular expression to see if it works. And then once we're happy with it and we see that everything's working, we can do a dry run on the code. We can see here that it has we can see here that it has detected these 3 keys, which I put into a text file at the root of the project. So once we're happy with that, we can publish the pattern, and it will be part of the regular secret scanning. If we go to the security tab, we can see that some secrets have been detected. Some of these should be the ones that we just came across, the my pattern that I created. But we can also see some other keys that have been created. It will show you within the source code where it's located, and it will give you the option to close it if it's a false positive or it's used as a test, or for whatever reason you decide that it's not going to be fixed. So if we look back at the code scanning, that sums up secret scanning. But if we look back at code scanning, we see a new option called check failure. And what this allows you to do is decide what level of alert will you not allow to be merged into the main branch of your project. So at the default setting is high or higher. If there's a high severity or critical severity vulnerability found, it will automatically block it from entering or being pulled merged into the main branch. I think we probably are still working on the scanning, so it has not yet completed. Let's check the actions. It's still going. So while we're waiting, I'll go back to dependency graph and dependabot. So dependency graph, if we enable this, it will create, under the Insights tab, it will create a dependency graph, which will list all of the dependencies of the project and transitive dependencies, so dependencies of dependencies. Also here, if there is an alert that has been raised or a vulnerability discovered for one of the dependencies, it will indicate here, the color will change, and you'll have an indicator that there's an issue. I don't see any at the moment, but this is still running, so it hasn't completed. So back in the settings for dependency check, we have dependabots, which is our tool for how to deal with alerts that have been raised against dependencies. You have the option to raise an alert, so you'll just be alerted whenever a vulnerability in a dependency is found. You can set it to automatically create a pull request when a dependency alert is found, or you can set it to automatically fix or automatically update the dependency if an alert has been discovered. In this case, I'll just set up for alerting, and you'll see that we should get several Dependabot alerts. And here are all of the different alerts that we have. You can filter by package, by ecosystem, manifest, and severity. And if you click into one of these vulnerabilities, you can see exactly where it's located, and it gives you the option to update it. It also gives you the option to dismiss the alert as well. So that covers dependency graph and Dependabot. I want to go back to the security tab and look at code scanning. I can see that there are many more alerts. So I believe that code scanning has completed. And just like dependency bot or secret scanning, you'll get a list of all the different alerts that were found. You can filter based on tool. So in this case, we have CodeQL and another tool that were used. You can filter based on the branch of the repository. You can filter based on rule or severity. So in this case, we'll take one here at the bottom, which is a SQL injection and vulnerability. So query built from user-controlled sources. And what we're first presented with is where this vulnerability exists, both the file and then the location within the file that the vulnerability exists. So this is where it's actually the dangerous section of the code. If we want to investigate further, we can go to show paths, and it will show us how this flows through the application from the source to the sink. So where it's actually executed and can do something dangerous. So in this case, we see that the program takes a name parameter from the user and it sends it to several methods, but it doesn't do any sort of sanitation on that input. And right in here, you can see that it concatenates it right into a query string without doing any sort of check, and then executes it against the database. So, in this case, this is a legitimate SQL injection vulnerability, and it needs to be fixed. So down here, you can see information on what an SQL injection vulnerability is, and you can also see recommendations for how to fix them. And you have example source code, example bad source code, example good source code. And this will show the developer how to fix these types of vulnerabilities. In this case, we have other examples, both bad and good, as well as additional references that they can check if they want to read further on. So in this particular case, this is a legitimate vulnerability, but if it weren't, they also have the option to dismiss the alert as they think it's not relevant, or it's a false positive, or it's used in a test environment. So there is no vulnerable, nothing is vulnerable. Okay, so that covers code scanning alerts. I'd like to go to the organizational level of this, the organizational level, and we can take a look at the security overview section. So this is the one pane of glass, which shows you the overall status of security within your organization across all of your repositories. There's a breakdown of Dependabot alerts, all the critical highs, mediums, lows, code scanning, and secret scanning. You also have, on the right-hand side, you can see the coverage of each of the tools. And we see here that code scanning, for example, is not used in most of the repositories. So if you're doing a migration or you're doing a phased approach for an implementation, you can check the progress here. This is a really good overview for people that are not within the development organization. So your information security teams, your audit, if there's an audit, this is a good thing to provide. And down here, we have a breakdown of a repository by repository breakdown of where they stand in terms of these, in terms of the overall security level. Here in this demo that we're playing, this was rated high because there's over 100 Dependabot alerts, over 200 code scanning alerts, and 5 secrets that were detected. If we click in here, it just takes us to the repository that we were in. So back in this security overview tab of the demo repository, Just two more things I'd like to show you. One is the policy tab. So what the policy tab does is it creates a security MD file within the root of the repository, and this allows you to tell developers and users of the repository what are the security policies for this particular application. So mostly, it's the most important part is reporting a vulnerability. So if somebody finds a vulnerability or they think they found something, how do they report it to the development team? How do they report it to the maintainer of the project? There's also an advisories tab. And what this does is allows people to raise a security advisory without in secret. So, issues are something that everybody can see. Security advisories are something that only the person who raised the advisory and the maintainer are able to see. So it keeps it private until a fix has been created. So if you click in create a new advisory, you can choose the ecosystem. So say Maven, you can choose the package name. You can choose information about the versions that are impacted, the severity, if you want to give it a severity. If there's a CWE number or there's a CVE identifier, you can also provide that here. And you have a title. So new advisory. And GitHub is also a CVE naming authority. So it gives you the option after we create this draft. So you can see the new advisory here. It gives the option to request a CVE from GitHub. So GitHub will review it, and if applicable, will assign a CVE number for you. So that concludes the overview of GitHub Advanced Security. Thank you all for your time.